Hello, how are you? We're here to continue with our new series. As usual, we are currently on calculus, where we said we'll have the code, where the code is MTH102. That's the code for this new series. And what we hope to achieve is calculus. Now, in today's class, we are going to talk about the algebraic combination of functions. Algebraic combination. Combination of functions. That's what we will be looking at today. Now, in our previous class, if you can remember, we've known what a function is. We've tried to determine when the association is injective, surjective, or bijective. We've also tried to determine the range, having given the domain of a function, determining the domain, the range of the function as well. We have also studied how to determine the shape of different functions by taking the graph of both the range and the domain. And we saw that life was really beautiful. I know that we have also learned about, in a case where the domain is not given, but just the relation given, we were able to determine the domain and the range from such relations and also identify them if they are functions and they are associations. We also plotted graphs in the various cases. We have also learned all that. And before we concluded in the previous class, if you can remember, we have also learned about how to determine a function from a graph by using the vertical line test. And we said if the vertical line touches the graph in one place, then we are saying that that is a function. But a case where the vertical line touches the graph in two places, then that is not a function. And we have also learned that all functions are relations, but not all relations are functions. Now today, we are going to look at the algebraic combination of functions. Now, in this class, we will be looking at different 1, 2, 3 multiple functions and how we can combine them, either by adding them or subtracting them. We can also carry out an operation by carrying the product, by multiplying them, or by taking their division. And we can also go ahead to consider special cases where we'll look at the inverse, the reciprocal of functions, okay? And then we'll see as we go on, I believe we're going to enjoy every bit of what we're about to say. Now, let's consider, having known what a function is, let's consider some functions, say f of x. Let's also have another one, say g of x. There is also the possibility that we can also have h of x and so on. Now, if we have all these as functions, meaning that this is a function of x, g here is also a function of x, h is here is also a function of x. Now we are saying that we can carry out algebraic operations on them if and only if they all have the same domain. if they all have the same domain. If they have the same domain, then fine. We can carry out algebraic operation. Now, for that of addition, let's look at it. For that of addition of functions, for that of addition of functions, let's assume we have f plus g all of x, this kind of expression. We are saying that where this is also a function, this is also a function, all of x. If we have this, we are saying that this is the same thing as f of x plus g of x. F of x plus g of x. So whenever you see something in this manner, we are saying that it's the same thing as this. Now, if we have, say, h of g all of x, based on what we have written, this also implies that we can also write these functions like this. If you do this, this is correct. Now, what if we choose to have the entire three? Like we are having f plus h plus g all of x. We are saying that this is also possible where we have f of x plus h of x plus g of x. Okay? This is also possible, provided their domains are the same. Now let's consider some examples with these that we have. For example, now if we have our f of x given a function, say, 2x squared minus 3x plus 1. And we have h of x as x raised to power 3 plus x raised to power 2 minus 5. And let's say our g of x is equal to just 5x plus 2. If we have these, look at these three different relations. Now we are saying that functions, then we are saying that we can carry out a combination. Now the question is, find one, f of g all of x. 2, f of h all of x. 3, h of plus g all of x. Then 4, if we are interested in f plus g plus h all of x. Then what do we do? Now remember the definition that we have given, that if we have it in this way, then it implies that this that we have plus this that we have. Now, meaning that for this, we are to have f of x plus g of x based on the definition that we have. where we have our f of x as where we have our f of x as 2x raised to the power 2 minus 3x plus 1. This is our f of x plus g of x, which is this, where we have 5x plus 2. Now, if you look at them, they are all polynomials. So you can combine them. Now let's try to combine them. Here, the degree of this is 2. Here, there is no expression term that has a power 2. So we bring this one down. Say 2 raised to power 2. Now here, the degree of this one term here is, this term here, the power here is 1. And we have another one that of its like. But here we have minus 3x. Whereas here we have positive 3x. So if you combine them, you are going to have plus 2x. Now this is a constant, this is also a constant. Here you have positive 1, here you have positive 2. So when you combine them, you're going to have plus 3. So we are saying that when you take the addition, the combination of these two terms, that this is what we have. So in other words, we are saying that f of x plus g of x is equal to 2x raised to the power 2 plus 2x plus 3. That's what we have. You can see that this is pretty simple. This is pretty simple. Now, if that's true, then we can go ahead to determine the other ones. We can go ahead to determine the other ones. Now, let's look at the second one, where we have f plus h all of x. Now, based on what we have, this is equal to f of x plus h of x, where we have our f of x as 2x squared minus 3x plus 1 for the f of x, plus for the h of x, we have x cubed plus x squared minus 5. That is what we have. Now, if this is true, then we can begin to combine them in collect like terms. Now, here we have 2x squared. Now, here we have the first term here is the power here is higher. Then let's bring this one first, where we have x raised to power 3. Then when the power here is 2, we have another one that is 2. But here we have 2x squared. Here we have 1x squared. Now, if you add them up, you are going to have 3x squared. Now, here the power here is 1, but we have negative 3x. Here, we don't have anyone that has just x. So we'll bring this one down, 3x. Now, the other one now is a constant, which is 1, positive 1. Here is a constant, but it's negative 5. When you combine them, you are going to have minus 4. So this is what we have. So what are we saying? We are saying that f of x plus h of x is equal to x raised to the power 3 plus 3x squared minus 3x minus 4. Now you can see that this is also pretty simple based on what we have. Now, I'm expecting the audience to do this following the same pattern. But let me do the number 4 so that we can really appreciate the goodness of mathematics. the audience should do this, then we are going to do this so that we will appreciate this. So that we will appreciate that. Now, what we want to do is this one. So we have, that's number 4. Number 4 is f plus g plus h, all of x. Now, based on the definition, this one is the same thing as f of x plus g of x plus h of x, where you have your f of x as 2x squared minus 3x plus 1 plus g of x, which is this, where we have 5x plus 2. Then we have plus h of x, which is this, where we have x raised to the power 3 plus x raised to the power 2 minus 5. That's what we have. Now, based on these that we have now, all that we need to do is to collect like terms. Now, the highest power here is 3, which is this term here. And there is no other one, so let's bring it down, meaning we have x raised to power 3. Now, followed by x raised to power 2, and we have 1 here. Here we don't have, but here we have another one. So, but here we have 2x squared, and here is 1x squared. So, if you combine them, you are going to have plus 3x squared. Now, for just the x terms, we have 1 here, we have 1 here, but here we don't have x term. So, we add this one. Here we have minus 3x, whereas here we have plus 5x. So if you combine these two, you are going to have plus 2x. Now, after the x term, the next one is the constant. Here we have a constant, here there is a constant, here there is also a constant. But here we have positive 1, here there is positive 2. So combining this, we have positive 3. But here we have minus 5. So if we bring that in, we are going to have minus 5, so we are having minus 2. This and this will give you minus 3, then minus 5, so we have minus 2. That is, we have minus 2. So that's what we have after combining all, meaning that f of x plus g of x plus h of x is equal to x raised to the power 3 plus 3x squared plus 2x minus 2. So you can now see that the addition of functions is just pretty straight away. This we can do if they have common domain. Now, in like manner, we can also consider the subtraction of functions. Subtraction of functions. This we can do considering the subtraction of functions. Subtraction. But before I go for the subtraction, let me give some examples that the audience may do. I want the audience to find this. Find f plus g of x if given that f of x is equal to 7x minus 5, and g of x is equal to 3x plus 2. I want you to find this. I want you to find that. Now, as you are doing that, let's go ahead to consider the subtraction of functions. Then we take subtraction. Subtraction of functions. Now, in this, we can also consider, rely on these that we have gotten before. But all that we need to do is, this time around, the operator here, addition operator here, will now change to minus. Will now change to minus. Now, for the subtraction, we have f minus g, all of x, a similar way. This is defined as f of x minus g of x. That's the meaning. If we have h minus f, all of x, it implies this is equal to h of x minus f of x. And we can also take more than two functions combined or subtract, carry out this operation more than two functions. Like if we have, say, f minus g minus h all of x, this we can also have as f of x minus g of x minus h of x. That's what we have. Now let's try to consider these using these terms to see how it will look like. Now, based on what we have, is more of like the other one that we have done. It's more of like the other one that we have done. So what is expected in this first case is taking this minus this, which is this. Knowing that our f of x is this and our g of x is this, therefore, f minus g all of x is equal to f of x minus g of x. And this is equal to, our f of x is 2x squared minus 3x plus 1 minus plus 1 minus g of x, which is 5x plus 2. That is what we have. Now, in this case, you can see that the operator here has changed from addition to subtraction. Now, this sign here is affecting everything here. The sign in front, remember, the sign in front of every number affects that number. Okay? The sign in front of any number affects that number only. Now, this sign is in front of this one, so it's affecting this one. Now, the bracket means it's affecting all. If there is no bracket, we would have said only this. Okay? Now, meaning this thing, this negative sign is affecting affecting all of them because of the bracket. It means it's affecting all. Now, meaning that what we have here is 2x squared for here. This is what we have in this place. Now, when we introduce this in, we have minus 5x minus plus will give you minus 2. That's what we have. Now, let's collect like terms. If we collect like terms, you can see that the highest power here is this. So we have 2x raised to the power 2. Now we have x terms are 2 here, but you have minus 3x. Here is minus 5x. So when you combine them, you are going to have minus 8x. Then here we have the constant, here we have the constant, but here is positive 1, here is negative 2. So when you combine them, you are going to have minus 1. So that we can say f of x minus g of x is equal to this. So you can see that this is also pretty simple and straight away. In like manner, we can also consider that of h minus f of x. H minus f of x. So here we have h minus f all of x will be equal to h of x minus f of x. That's what we have. That's what we have. Now, our h of x is this. Is clearly explicitly written. So we have x raised to the power 3 plus x raised to the power 2 minus 5 for that of h of x. But for x of x, for f of x, we have minus, because of this, minus f of x, we have 2x raised to the power 2 minus 3x plus 1. That's what we have for that of f of x. So what we need to do now is, remember, as I said in the first case, this negative sign is affecting everything inside here because of this bracket. So if you open the bracket up, you are going to have, let me write this side first. So meaning that you have x raised to the power 3 plus x raised to the power 2 minus 5 in this one. Then this coming into this will be minus 2x squared. This coming into this minus times this will give you plus 3x. This one times this will give you minus 1. That's what we have. Now all that we need to do is to collect like terms. If we are collecting like terms ranging from the highest power, we have x raised to the power 3. We have x raised to the power 2 here, 1. Then we have negative 2x raised to the power 2. So if you combine these two here, we are going to have minus x raised to the power 2. Then the other one is 1x. Here there is no 1x, but here there is 1x term here. So if you bring this one in, we are going to have just plus 3x. Then the last term is the constant term. Here we have minus 5, here we have minus 1. So when you combine them, you are going to have minus 6. So that we're saying h of x minus f of x is equal to this that we have. So you can see that this is also pretty simple. It's more like the first one, only that the operator has changed. Now, lastly, we can consider this other one where we're dealing with more than two functions, two terms, two functions. So, in doing this, this is also pretty straight away. If we are interested in this, then we are saying that f of x is this. This we have as 2x squared minus 3x plus 1 for the f of x minus g of x. G of x is this, and we have 5x plus 2 minus h of x, where h of x is x raised to the power 3 plus x raised to the power 2 minus 5. Minus 5. That's what we have. If you look at it, you see that is pretty simple. Now, as we did in the other cases, we can open this bracket because this term here is affecting these brackets, all the terms here. Now, this sign here is also affecting all these terms here. So, if we want to open them up, then we have 2x raised to the power 2 for this, minus 3x plus 1. Then allow this one to come in so that we have minus 5x. If this one comes here, it will be minus 2. If this comes here, it will be minus 3 raised to the power, x raised to the power 3. This comes here, it will be minus x raised to the power 2. This one comes here, it will be plus 5. That's what we have. That's what we have. Now, the next thing is to open the bracket up as we did in the other case. Now, if we open the bracket, the next thing is to collect a like terms as we did in the other case by starting with the highest, the term with the highest power. The highest power term is this, and which is negative, and we have negative x raised to the power 3. Followed by that of x raised to the power 2. Here we have 2x raised to the power 2, and here we have negative just 1x raised to the power 2. So if you combine these two, you are going to have plus x raised to the power 2. Now the next one is the 1x terms. Here we have minus 3 of it. Here we have minus x, minus 5. So if you combine these two, we have minus 8 already. Minus 8 here, so that we have minus 8. Then the other one is the constant terms, which is this plus 1 minus 2, which is minus 1. Minus 1 to this will give us plus 4. Plus 4. So we have plus 4. Plus 4. That's what we have. So we are saying that f of x minus g of x minus h of x is equal to this term. So you can see that this is pretty good. Now, having done this, I want us to consider, the audience should consider this pretty simple example at home. Do this at home. Now we are saying that you should find h minus g all of x, where h of x is equal to 2x plus 2x, where h of x is minus 3x squared plus 2x plus 4, and g of x is equal to minus 8x squared minus 8x. Now I want you to carry out this operation to see how the kingdom will look like. Now the next thing that I want to talk about is multiplication of functions. 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 Now, in this one, it's more of like the other one, but here we are expected to multiply the functions. That's what's expected. That is, if we have, say, f dot g all of x, that this we can write as f of x dot g of x. If you don't want to write it this way, then we can also say, if you don't want to write it this way, then this we can also write as f g all of x, they are all the same, will be equal to f of x g of x. Okay? So this is also very simple and straightforward. Now, in like manner, you can also combine more than 2, and you have f, g, and h, all of x. This you can also have as f of x, g of x, then h of x. This you can also carry out in this manner. Now let's consider few examples using this to illustrate what we have said. Now, if we want to do this, then it is also pretty straight away. So if we say we are interested in h of g or h of x, all of x, h of f, all of x, we're saying that this one is the same thing as h of x, f of x. Okay? This is one term, two term, the third term. Now let's carry out some operation by using this to demonstrate what we have. Now, if we are interested in f of g all of x, we are saying that this is the same thing as f of x, g of x. Now remember that our f of x is this, and this we have as 2x raised to the power 2 minus 3x plus 1. And g of x is this, where we have 5x plus 2. 5x plus 2. So you can go through this simply by opening the bracket up. Now, this multiplied by this, we are going to have 10 x raised to the power 3. This to this will give us plus 4x raised to the power 2. This to this will give us minus 15x raised to the power 2. This to this will give us minus 6x. This to this will give us plus 5x. This to this will give us plus 2. Now the next thing that we're expected to do is to carry like terms, collect like terms. Now, if you look at this one, the highest power is this, so we have 10x raised to the power 3. The other one is these terms, where we have raised to the power 2. Now, if here we have plus 4, here is minus 15x squared. So if you do this, you are going to have minus 11x squared. Now here we have this. Here is minus 6x. Here is positive 5. So if you combine them, you are going to have just 1x. Then lastly, you have 2. So we are saying that f of x multiplied by g of x is equal to this term. So you can see that this is also pretty simple and straight away. Now the next one I would want us to do is I want the audience to look at this. Okay, let me do it. Let me do it so that we'll enjoy what we are doing. We have done this. The next one is this that I want to do. And here we say we have h f all of x is the same thing as h of x, f of x. That's what we have said. So let's try to do this to see how it will look like. H of x, based on this definition, h of x here is this term that we have. And we have it as x raised to the power 3 plus x raised to the power 2 minus 5 times f of x, which we have as 2x raised to the power 2 minus 3x plus 1. That's what we have. Now, if you open this up, what do we have? What do we have? This to this will give us 2x raised to the power 5. This to this will give us minus 3x raised to the power 4. This to this will give us plus x raised to the power 3. This to this will give us plus 2x raised to the power 4. This to this will give us minus 3x raised to the power 3. This to this will give us plus x raised to the power 2. Lastly, this to this will give us minus 10x raised to the power 2 minus 10x raised to the power 2. This to this will give us plus 15x, and this to this will give us minus 5. Now, if you collect like terms here, starting with the highest power we have, 2x, we have 2x raised to the power 5, followed by this one raised to the power 4, we have another 4 raised to the power 4. If you combine these two, you are going to have minus x raised to the power 4. We have this here, we have this here. If you combine them, we are going to have minus 2x raised to the power 3. If you come here and you come here, we are going to have minus 9x raised to the power 2, x raised to the power 2. Then lastly, we have this, and here we have plus 15x. Then for the constant terms, we have only this, and you say you have minus 5. So when you take the product of these two terms, these two functions, this is what you have. This is what you have. This one coming here, this one and this one give birth to this. This and this give birth to this. This and this give birth to this. Then this one is this, and this one is this. So that's what we have. Then lastly, we can also do business with this one where the three terms are. First of all is this to this, which we have done here, and we have the answer as this. The next thing is for us to just add h. Already we have done this and this, which is this. Then the next one is just to add h. So if we add h to this one, meaning that we are saying f of x, g of x, h of x. Now, we have done this and we have this, meaning that this is equal to 10x raised to the power 3 minus 11x squared minus x minus x. This one is this one, and this one gives you this, and this gives you this, then this one. This one is plus 2. So we have plus 2. We have plus 2. For this, then we are saying that this term now is multiplying the h term, which is this, which is x raised to the power 3 plus x raised to the power 2 minus 5. And this, the audience can also do straight away as we have been doing. By use this to multiply this, 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 and finally this, then you begin to collect like terms. These are also given as an assignment. I want the audience to look at this to see how the kingdom will look like. Now, having said this, the next thing that I want to just briefly talk about is division of functions. Division of functions. Division of functions. For division of functions is more of these ones that we have done, only this time we are having them in terms of numerator and denominator. Now, based on what we have been writing, in case we have a function, say, f over g, all of x, we are saying that this is the same thing as f of x, everything over g of x. So this is also pretty simple. This is also pretty simple. Now, let's give, say, f of x is equal to this and this. All that you do is just to position them in their various, place them in their various positions. Now, I want us to look at this. The audience, if this is the definition that we have, then I will want us to look at this. I will do one, I will give two cases, or maybe three. Then the audience will do two or one, as the case may be. Now let's look at it. If we have given that f of x, given that f of x is equal to 2x raised to the power 2 minus 3x minus 1, and we have g of x is equal to 5x plus 1. Now, the question is find f of g all of x. That is in one case. Now, if we also have h of x as x raised to power 2 plus 3x plus 2. Then we have, say, b of x equals x plus 2. Then in this case, we are interested in find h over b all of x. That is one case. Then lastly, if we have another term, okay, let's go with this one. If we have, say, p of x is equal to, if we have p of x is equal to, say x plus 3, then we have y of x is equal to x squared minus 9. Now the other question is find p over y all of x. All of x. Now the first case that we have is also very simple. All of them are pretty simple. Now for this we have f of x all over g of x. And f of x we have as 2x squared minus 3x minus 1 all over g of x, which is 5x plus 1. And that's all. Can we simplify it further? No. So you just leave it in that form. The other one that we have is h over b of x, meaning that we have h of x all over b of x. And this is equal to x raised to the power 2 plus 3x plus 2 all over x plus 2. Now, if you look at this, we can simplify the numerator further. We can simplify the entire term further. If we simplify, then we are going to have x. If we factorize this numerator, we have x plus 2 into x plus 1 all over x plus 2, which is this one. Now, because this times this will give you this times this will give you 1x, this times this will give you 2x, plus the other 1x will give you 3x, which is this, then this times this will give you this. So this one is the same thing as this. All that we have done is we have just factorized it. And we are factorizing it because the numerator is looking like one part, which we can further simplify. And if you romance this further, all that you will be having is just x plus 1 as a term. So if you take this, the division of these two terms, this is what you are going to have. And in like manner, if we have p for this other last one, it implies p of x all over y of x. All over y of x. And p of x we have as x plus 3 all over y of x we have x squared minus 9. If in this case, if you look at it, the denominator can also be further simplified as x plus 3 all over x minus 3 into x plus 3. That's what we have. This one is the same thing as this. How? this times this will give you this. This times this will give you positive 3x. This times this will give you negative 3x, and those two are off the job market. And this time this will give you negative 9. So these two, this term is the same thing as this. Now if that's true, then this one and this is also the job of the job market, so that you will be left with 1 all over x minus 3. That's what you have. When you take this, that is what you have. So you now see that considering the algebraic combination of a function of functions is quite an interesting thing that we have seen. Now, next, I will just want us to briefly consider some special kinds that are also common. Some special kinds that are also common. And one of them is the reciprocal of a function. 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 And in it, we have it as 1 all over the function. This kind of expression, as we have here, assuming that this part here is a function. These are special kinds that we have. Now, in this one, as I have stated, if you have, in case, given that f of x is equal to maybe 2x plus 5, the reciprocal of this function is just simply 1 all over f of x, which is the same thing as 1 over 2x plus 5. That's just it. Now, another special kind that I want to talk about is in cases where we have the scalars being multiplied, where the scalars are real numbers, scalars being multiplied to the function. Scalars being multiplied to the functions. Scalars being multiplied to the functions. So you say, if we have, say, alpha and beta, if these are scalars, then we are saying that we can have these, they are scalars, where they are all members of the real number set. Then we are saying that we can also combine them to functions by having alpha f, say, plus beta g, all of x. This we can also write. If we have this, based on what we have, it simply implies that we have alpha f of x plus beta g of x, because these ones are constants. They are constants. They are constants. So if you have, just say, alpha of h, all of x, this one is the same thing as alpha h of x. And as we did in the case of 3 functions with 3 scalars, you can also have them in, you can also write them similarly as we have done for that of the addition of functions. Let's go into specifics. Let's consider some terms to see how the kingdom will look like. Like if we have a definition by saying, let f of x be equal to 3x minus 7, and let's say we have g of x, we have, say, g of x as 4x squared plus x. And the question is, find 3f plus 2g all of x. If you have this, this is also pretty straight away. You can see that in this case we have scalars at the front. Here we have 3, here we have 2. Now, based on the definition that we have here, we are saying that this one is the same thing as 3f of x plus 2g of x. So 3 will be multiplying this function f of x, and 2 will be multiplying this function g of x. And f of x is this. So we have 3 multiplying f of x, which is 3x minus 7, plus 2 going into g of x, which is 4x squared plus x plus x. Now, if you open the bracket up, you are going to have, this one will give you 9x minus 21, plus this to this will give you 8x squared. This to this will give you plus 2x. So there are like terms that you can collect in order to tidy the expression. If you collect those like terms, then you are going to have the highest power there is 8x squared. Then this and this will give you plus 11x and minus 21. That is what you have. So based on what we have, which is 3f plus 2g, we are saying that is equal to 3 f of x plus 2 g of x. The answer boils down to this, which is 8x squared plus 11x minus 21. So you can see that in cases where we have scalar products, the scalars multiplying the functions, we are saying that this we can also open up, and you will see that life is pretty simple and beautiful. Now, for the sake of this class, I want to halt here. At least with these that we have done in algebraic combination, I know that we are good to go. In this class, we have learned the things that we have learned now in this class is carrying the addition of functions, where we saw that life was reasonable. We have also considered that of subtraction of functions, multiplication of functions, division, and we've also considered special cases where we consider the reciprocal of functions, and in cases where scalars are being multiplied or attached to the various functions. And you see that in the end, life was beautiful. Now, in this case here, even if it's not addition, we can also combine that of scalars to the functions for that of the multiplication of functions. Okay? Scalars can also still be added. How do I mean? You can still have x of f of g, and this one all of x. This one is the same thing as this of f of x, then g of x. This you can also have. Okay? For that of the multiplication, for that of the subtraction, this you can also do, and it will go. all that you do is to allow the scalars that are in the front to multiply the function, then you carry out the operation, even if it's addition, the same, subtraction, the same, multiplication, division, as the case may be, then you see that everything is pretty simple. I thank you very much for your attention. And in our next class, I believe we're going to consider maybe the piecewise functions and other topics that will enable us to understand what functions really are. Thank you, and God bless you.